Hello guys, welcome to another video of Jeremix's life over here. Today we're going to talk about physics. I'm going to help you in physics, in the class of physics. And basically what we're going to learn are the nuclear reactions and atom nucleus from the chapter 39 of Crippens, as you can see over here. First of all, we have to see the key concepts, like the nuclear structure, nucleons, protons, and neutrons from the nucleus. Their combined number is the mass number. The number of protons defines the elements of the atomic number, while neutrons determine the isotopes, as we can read over here. If we can read, isotopes, atoms with the same atomic number but different neutrons, and isotones, same neutrons but different atomic number. Fundamental particles, the understanding that all matter is composed of protons, neutrons, and electrons, like here, and their basic properties. Atomic structure. Rutherford's model of a small, dense, positively charged nucleus containing most of the mass surrounded by electrons in a much larger, mostly empty space. Atomic number. The number of protons in the nucleons, which uniquely identifies an element of determined is its chemical properties. Mass number. The total number of protons and neutrons in the nucleus of an atom. Isotopes. Atoms of the same element, same atomic number, that have different numbers of neutrons. Atomic mass. The standard unit for expressing atomic and nuclear masses defined on 12, the mass of carbon-12 atom, its conversion to kilograms and energy, MeV. Mass defect and binding energy. The difference in mass defect between a nucleus and the sum of its constituent nucleons and the equivalent energy that holds the nucleus together. Nuclear force, the strong short-range attractive force that overcomes the electrostatic repulsion between protons and the nucleons. Radioactivity, the spontaneous emission of particles or electromagnetic radiation, gamma rays, like gamma rays, for unstable of atomic nuclei. Radioactive decay and half-life. The process by which unstable nuclei transform and the time it takes for half of the radioactive nuclei in a sample to decay. So I'm going to leave you some images here. And the equations, which are the mass number over the atomic number, bracket symbol, bracket equals A over Cx. And the mass energy equivalence is E equals mc squared, nuclear decay law, and parentheses T equals NOE to the power of decay constant to the power of time. And the half-life is time divided by its half equals ln times 2 over decay constant. And Q value, Q equals M initial minus M final, parentheses C squared. And the isotopes is B equals E over B, and EV equals MV squared over R. And over here we have some images where we can see the velocity sector, the photographic plate, in which it has a curvature, as you can see. And the question is R equals MV over EB and E equals MC squared. Over here we can see an exponential decay in the nuclear physics. I got some points off because not putting the X and Y, but here we can see the equation N equals NO, parentheses 1/2, parentheses 1. And here we can see some nucleons with some atoms where they separate each other. Here we can see an unstable atom and how fast neutrons are over here and slow neutrons are over here. So finally, we're gonna finish this video by explaining you the atomics, the variables over here. I will leave you a table over here, which is atomic number is C, no unit, mass number A, no unit, number of neutrons N, no unit, electronic charge E, coulombs, mass M, kilograms, velocity V, meters per second, electric field E, volts per meter, magnetic field B, Teslas, radius R, meters, force electric FE, neutrons, force. We have some issues, but we can continue. Unit fluid atomic mass unit U, kilograms, energy E, joules or mega electrovolts, speed of light C, meters per second, mass defect delta M, and atomic mass units, binding energy BE, and it's MeV, so mega electrovolts, and kinetic energy coulombs. So thank you for watching this video. See you next time.